Texan Global School. Solids. Sphere. This class discusses the general characteristics of the sphere, surface area, and volume calculation. The sphere is a solid bounded by a surface in which every point is equally distant from a point called center. The straight line from the center to any point of the surface is the radius. A straight line that passes through the center from one point of the surface of a sphere to another is the diameter. Slot and Lenz stated that a sphere's surface and volume may be approximated by taking the surfaces and volumes of a series of circumscribed polyhedrons, all of whose faces are made to decrease indefinitely. This assumption will be helpful in defining the surface area and volume of a sphere. Archimedes found precisely that the surface area of a sphere is the same as a cylindrical surface. So we can derive this formula by inscribing the sphere in a cylinder using the described principle. We can see that the height of the cylinder is the same as the diameter of the sphere, or the same as 2 radii. As seen in previous classes, the formula to calculate the cylindrical surface is 2 times pi times the radius times the height. Hence, substituting the height of the cylinder h by 2 radii results in the formula to calculate the total surface of a sphere as 4 times pi times the radius squared. Let's see a first example. Find the surface area of a sphere with 8 inches radius. First, sketch the sphere with the given measure. As seen, the total surface area of a sphere can be calculated as 4 times pi times the radius squared. By substituting the radius, results in a total surface area of 256 pi square inches. Using the calculator, it is approximately 804.25 square inches. The Cavalieri's principle states that if multiple three-dimensional objects have the same height and cross-sectional area over that entire height, they will have the same volume. We can visualize that despite the different areas, as a whole, all of them have the same volume. Let's derive the formula to calculate the volume of a sphere. Start by drawing a sphere and a double cone of revolution inscribed in a cylinder. The height of the cylinder is the same as twice the cone's height and twice the sphere's radius. Based on Cavalieri's principle, any sphere section is constantly equal to that of the solid between the circumscribed cylinder of revolution and the cone of revolution inscribed in the cylinder. Hence, the volume of a sphere is the difference between the volumes of the circumscribed cylinder of revolution and the cone inscribed in the cylinder. It was demonstrated that the volume of a cylinder is pi times the radius squared times the height. It was also analyzed that the volume of a cone is pi times the radius squared times the height over 3. Performing the algebraic fractions results in 2 times pi times the radius squared times the height over 3. The volume of a sphere results by substituting the value of the height h of the cylinder by 2 times the sphere's radius, which is 4 times pi times the radius cubed over 3. This is also equal to the surface area of a sphere times 1/3 of the radius r. In this other example, find the volume of a sphere with an 8 inches radius. First, sketch the sphere with the given measure. Using the formula to calculate the volume of a sphere, 4 times pi times the radius cubed over 3. Let S substitute the value of the radius. When solving results, a volume of 2048 pi over 3 cubic inches, approximately 2,114.66 cubic inches. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com